In this video, we're going to focus on the slope-intercept form of a line. So, like I said in the previous example, the slope-intercept form of the equation of a line is y equals mx plus b. M is the slope, and the y-intercept is 0b. And we can see that in the comment below. So if we let x equal 0, then this part of the equation goes away and we're just left with y equals b. Therefore, the point 0b is known as the y-intercept, which is the point at which the line crosses the y-axis. The slope is the steepness of a line. So it measures how steep it is, whether it's steep or maybe not as steep, and also whether it's going up when you read it from right to left or down. So we can see examples here at the bottom of the page. The slope of a non-vertical line is the number of units the line rises or falls vertically for each unit of horizontal change from left to right. So this line is rising, so this would have a positive slope. But in this line, for every horizontal unit that it falls to the right, it's actually falling vertically. So this line would have a negative slope. Once you have determined the slope and the y-intercept of a line, it is a relatively simple matter to sketch its graph. But first, we may have to put the line in slope-intercept form. And to do that, you have to solve it for y. So let's make a note up here. To put a line in slope-intercept form, we must solve the equation, and I'm going to abbreviate equation EQ apostrophe N for y. All right. So slope-intercept form means the equation is solved for y. So for this equation, it is not solved for y. So I've got to manipulate it. So anything that doesn't have y in it, namely this negative 6x, has got to go to the other side. And to do that, I'm going to add 6x since it's a negative 6x. If I add 6x to both sides, these will cancel. So I'm left with negative 3y. We can't add these two terms together because this one doesn't have x in it. So I'm just going to rewrite it as 6x plus 9. And I do that because usually in slope-intercept form, y equals mx plus b, your x term comes first. Now what I need to do is to divide both sides by negative 3. And I'm going to divide everything by negative 3. So these cancel to 1, so I have y is equal to 6x over negative 3 plus 9 over negative 3. So that's going to give me y is equal to negative 2x minus 3. Now that I have it in slope-intercept form, I can identify the slope and the y-intercept. So remember, the slope is the number in front of x. So we will write m is equal to negative 2. And I'm going to go ahead and make it a fraction by putting it over 1 because the slope tells us the rise of the line to the run of the line. And I'll show you what I mean when I graph it. The other number in this equation is negative 3. That is the y-intercept. So our y-intercept occurs, remember x is 0 and the y value is -3. So to graph a line using the slope and the y-intercept, we're going to start graphing by plotting the y-intercept. So I'm not going to go right or left, but I'm going to go down 3 and plot that point. Now I need at least one more point to be able to graph this. Well, you really only need 1 point, but because I don't draw very well, I'm going to put more than one. So what we're going to do is what I call walking out the slope. So remember, the top number tells you rise or fall, depending on whether it's positive or negative. And the bottom number tells you right or left, depending on whether it's positive or negative. So, since the top number is a -2, I'm going to fall 2, but then I'm going to go right, 1. And I can continue to do that. Fall 2, right 1. Fall 2, right 1. I can also think of -2 over 1 as +2 over -1. Both of those are equal to -2. So from this point, I can also go up 2, but then I would go left 1. Up 2, left 1. Up 2, left 1. So you can see the line forming. And so now I'm just going to connect these dots. And so this is the line y equals -2x minus 3. It's also the line -6x minus 3y equals 9. It's the same graph, it's just the line written in different forms.